Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Sir, we are learning a concept called combinational circuits. We have seen few combinational circuits up to multiplexer and demultiplexer we have seen, and even we practiced a few problems based upon those particular circuits. And now today we will try to move forward to the next combinational circuit, that is called encoder. Sir, please make a heading encoder. A very beautiful circuit and a beautiful analysis, encoder. The name itself indicates that encoder, it is used to make coding. It is used to convert one code to another code. Simply we can say that. Sir, let me write a point here. Sir, it is a combinational circuit. First of all, combinational circuit first of all, and then the important point is it is used to convert other codes to binary codes. A very, very important point. The second point, it is used to convert other codes to binary codes. Even this is a interview question also. Sir, even it is a multiple choice question also. Even in IAS prelims exam, most of the times this question has been asked. Which of the following code is used to convert other codes to binary codes? Even option A, encoder, option B, decoder, option C, multiplexer, option D, demultiplexer. We need to select option A, encoder. Sir, here what kind of codes it is used to convert? We can say the first type of code, it is used to convert. I told you in the third class itself. Even if you see my lecture number 3, even we will try to find there are 4 types of codes, which are, we can say that binary code. I told you in the first class, even binary code, and the second is octal code, third one is decimal, and fourth one we can say hexadecimal. These are the 4 types of codes we have seen. So now here encoder is used to convert octal to binary. Here it is used to convert octal to binary, decimal to binary, hexadecimal to binary, we can say that. Which means what I am trying to teach here is, it is used to convert all other codes to binary codes. Sir, here if you can able to concentrate 1 minute, you will understand the logic. Sir, here it is used to convert, first thing we can say that here octal code to we can say binary. Can you please just tell me, octal means we can say 8, binary means we can say 3, because 8 combinations, which means only 3 bits. Here 8 to 3 conversion is there. And now here decimal to binary, we can say. Decimal means here we can say 10 to 3 here. Now the third one is, we can say that hexadecimal to binary. Here we can say 16 to 4. What is 16, sir? There are 16 combination of inputs, and then here there are 16 combination of inputs, and it is producing 4 outputs, which means it is taking 8 inputs, it is producing 3 outputs. Here taking 10 inputs and producing 3 outputs, 16 inputs and 4 outputs. That is the input output combinations that we are going to see. Multiplexer, when you are studying, you may be having only one input and many outputs, so that we call it as one to many circuit. When we learn about a demultiplexer, there are many inputs and only one output. We said that is what we called it as many to one circuit and one to many circuit. Those things we have seen. Coming to encoder, it is not having a single input and it is not having a single output. It is having a defined inputs which are here. If it is converting octal to binary, it is having 8 inputs and 3 outputs. When it is converting hexadecimal to binary, it is having 16 inputs and 4 outputs. That is the speciality of encoder. And now let us try to see one more thing here. There are 2 types of encoders. Third point is 2 types of encoders. First, 2 types of encoders. The first one is basic encoder. Basic encoder. And the second one is, we can say, priority encoder. Priority encoder. Sir, basically most of the times in questions in competitive exam point of view, we may get the question from here, this priority encoder. Nobody can ask a question from basic encoder. But if you are not able to understand a basic encoder, you are not able to understand even a single point about priority encoder. This is completely a following procedure or consecutive procedure of a basic encoder. We must be able to understand basic encoder first of all. Let us try to understand. Please note all these points, very, very important. And now next, make a heading, basic encoder. Note it down. Yes. Now just to make a heading. Sir, we have seen already, encoder is a combinational circuit which is used to convert other codes to binary code. What are the other codes, sir? First other code is, we can say, octal code. Here encoder, we can say conversion from basic encoder. Here we can say 8 into 3 encoder. Simply 8 into 3 encoder means, first point we can write this circuit used to convert octal to binary conversion. Sir, here based upon the question, we can write the things. How many number of inputs are, sir? Here we have 8 inputs. First point, number of inputs and outputs. If you see, there are 8 inputs. Here inputs are 8 and outputs are, we can say that, 3. So this is what. And now the second thing, I just want to write the block diagram. The block diagram of 8 into 3 encoder. So this is 8 into 3 encoder. Here the 8 inputs are 1, 2, 3, 4, 5, 6, 7, even 8. And there are 3 outputs which are 1, 2, 3. Sir, can I call all these inputs as I0, I1, I2, I3, I4, I5, I6, I7? Yes. And now here the outputs I want to call as Y0, Y1 and Y2. And finally, sir, we have one more point left over for this particular block diagram. When we learn multiplexer demultiplexer concept, we have seen the one more important point is a select line or control line. So based upon the select line or control line, even multiplexer inputs are transforming the data from input to output we have seen. But coming to encoder and decoder, here the important thing is, sir, here instead of encoder there is another input called here enable. Say along with me, enable. Enable pin is there. E for enable. Here enable is 0, which means input will not able to transfer from input ports to output ports. When enable pin is 1, then only the input data will be transferring to output data. That is the importance of the circuit. And now let me see the second point here, truth table. Truth table. Let us try to understand even truth table also. Sir, here we have 8 inputs which are I0, I1, I2, I3, I4, I5, I6. Here enable pin, and we have 3 outputs. Sir, now the first, when we are drawing a truth table, the first foremost important thing is enable pin. And now here inputs are, we can say I0, I1, I2, I3, I4, I5, I6, I7, even we can say up to I7 we will be getting, because we are counting from I0. And we have 3 outputs. Can you please just tell me outputs? Y0, Y1, we can say Y2. This much big a truth table we are going to fill. Sir, here these are the output and this is enable input. Sir, remember one thing always when you are trying to draw a encoder, decoder, truth table. Here suppose here enable input is 0. Suppose here enable input is 0, which means here, which is, we can say that this is a power switch, power on off switch. If this is enable input is 0, which means the entire circuit is power off stage, so that there is no connection from this input body to output data. Here there is no connection established between input to here input to output. There is no connection when E equal to 0. So now what is the thing that I want to convince is, here always we will try to give enable input is 1, so that only the input data will be transferred to output data. Sir, the moment, the first thing here, suppose if you enter E equal to 0, what is happening, sir? Even all the inputs data will be 0, because all the inputs data will be 0. Even because input data is 0, output data is also 0. Why output data is completely 0? Because input is 0. Why input is 0? Because enable is 0. So that is the sequence to understand. And now coming to the second thing. Suppose if you make enable is 1, what is happening, sir? Suppose if you make enable is 1, automatically enable is 1 means here the input I0 will be enabled. Here input I0 will be enabled. Suppose here enable is 1, not only I0, one of the inputs will be enabled at a time. Only one of the inputs will be enabled, not at a time. Here I0, I2, I3, I4, something like that. So many number of inputs will not be available. Only one input will be enabled, and based upon that enabled input, data will be converted to binary. Sir, suppose if I0 is enabled, which means I0 is transferring the corresponding binary data I0, we can say 0, 0, 0. Suppose if here I3 is enabled, which means here the corresponding binary 0, 1, 1 will be converted. That is the sequence, that is the secret of this here, the concept behind. Now here the moment, the first thing enable is 1, so that I0 is enabled, all remaining will be 0. All remaining will be 0. The moment when I0 is transferring, I0 is converting octal data to binary, which means here I0 position is 0. I0 position is 0, position is 0's binary data is 0, 0, 0. And now coming to enable input is 1. And now here I want to enable 1 instead of 0 and all others are zeros. What is the outputs are here? Here one's binary is, we can say 0 0 1. That is the thing. And now the next thing, enable is 1, and now here I0 0, I1 0, I2 will be 1 and all remaining things are 0. Now 0, here we can say that 1 0. This is the thing. Sir, are you following what I am trying to convince? What I am trying to convince you, please try to follow. Here what I am trying to tell is, the moment when enable is 0, then all inputs are disabled, so that output is also disabled because inputs are disabled. The moment when enable is 1, automatically one of the inputs out of available all, one of the inputs will be enabled, so that that particular corresponding to that particular input, the output will be produced based upon the weightage of that particular input. Now here the enable input is 1, and now I want to make I3 is enable, so that 0, all others are zeros. Here sir, this is third weightage, so that 0 0 0, we can say 1 1. And now here if you want to see here 1 2 4's place, so 2 plus 1, when we make these two are ones, we can say 2 plus 1 3. And now here also 2 means here seconds place 1 means here all zeros, there is no 1. And now the next enable is 1, so means I4 must be 1, all remaining things are zeros, all remaining things are zeros. This is I4. What we should do, sir? Here 2's place must be 1, and now here we can say that 1 0 0 we can say. And now here the next 1 enable is 1 0 0 0 0 0 even 1, which means here 5 must be there, so that output is 5, so 1 0 1 we can say. And now here the sixth one 0 0 0 0 0 0 1 and 0, we can say 1 1 0. And finally when we give enable input 1, all are zeros, and finally only 1, we can say this is what, these are the 3 ones. Sir, can you please try to understand here, when the moment only the moment when we are giving inputs here based upon the corresponding weightage value, then only output is converting. If you see here, this is, we can say 0 1 2 3 4 5 6 7, this is the decimal weightage. So now here if you can see that fifth one, the enable is 1, and now fifth place I5 is 1, and now the corresponding binary is 1 0 1. 1 means here fourth place weightage 4, and now here one's place, here we can say 4 plus 1 is weightage 5. So this is how the data is converting input, whatever the input is data we are applying, the data is converting to binary data. This is what binary data, we can say 4 to 1 binary data. Sir, this is how we can convert data, input data to output data. And next thing, let us try to write the logical expression. Logical expression, let us try to write the logical expression for the given truth table. Here third one, logical expression. Logical expression. Sir, always we will try to write a logical expressions for outputs. We can say the first output is y0, and the second output is, we can say y1, and third output is, we can say y2. Can you please just tell me what are the places where the output is enabled? We can say here these are the 4 ones, and now the corresponding values are, we can say this one, and now the corresponding value is this, and here the corresponding value here the corresponding value. Can you please just tell me what is the positional weightage of this input? I4. And now here Y0 equal to I4 plus next I5 plus I6, we can say I7. This is the equation. And now coming to the second one, we can say Y1. These are the two outputs, and here these are the two outputs enabled. So the corresponding input is this one. Here also the corresponding input weightage is this one. We can say both these are I2 and I3, we can say. Sir, here I want to write I2 plus I3, and other two are here, we can say I6 and I7. Here I6 plus I7. And now coming to the last one, Y1 is here the first one, 2, 3, 4. And what are the corresponding values? Here first one is I1. The next one is here, we can say, if you see that here this is I3. And now I3 plus even I5, even I7. These are the logical outputs, we can say that. These are the outputs of encoder. And now based upon this analysis, even we can understand here the priority encoder also. Even we can see the priority encoder concept in the next class. Thanks for watching. Please do subscribe.